Hi, I'm Leona from InMax project. I'm an architect of InMax. InMax is a stateless ZK rollup, and it will make it serve a global purpose system. It enhances the whole Ethereum layer 2 world. Today, I want you guys to build a layer 2 interoperable application that traverses over layer 2s. Let me explain the overview of InMax first. Stateless means that validators do not need to have databases. Instead of validators, client-side logic can validate each transaction. In Intmax, the client-side logic is infinite recursive ZKB. What is infinite recursive ZKB? Recursive ZKB is a ZKB verifying another ZKB proof. Infinite recursive ZKB repeats this process unlimited times, unlike usual recursive ZKP. Infinite recursive ZKP can verify the whole chain of ZKP by verifying only one previous ZKP proof. Once you verify the previous ZKP proof, that has already contained the proof prior to that. Also, the proof contains the proof prior to it, so the proving chain reaches the origin of this chain. How to remove the transaction data from layer 1 code header? This is one of the most important parts. We introduced limited online requirements to ZK Rollup, and this improved both efficiency and privacy. This algorithm removes almost all on-chain data from ZK Rollup, so it's 95% cost reduction compared with other ZK Rollups. A validator returns their market proof of the result of transactions to users after they send transaction to the validator. This proof can be used for withdrawing assets to layer 1 with ZKB. A double spend or double exit is impossible by the non-movement proof, which is using non-inclusion proof, like SMT. There are aggregated lists of transactors in code header. This is how InMax works statelessly. Only the market root of the many transaction hashes and deposit is recorded in layer 1 as described. The users will merge the transaction to their off-chain storage by client-side ZKB. If we have the result data of smart contract executions from the other layer 2s in this depository, like this, we can use these states for conditions of token transfers and minting. Okay, next, let's start building an application. First, install the tools to use Intmax. Clone the repository from Intmax Rollup CLI. Open the terminal and git clone. Build the CLI according to the README. Check if last is installed. If not, please install it beforehand. Build the CLI. If you see something like this, when you're done, you have succeeded. Configure area settings for easy use of CLI. Run the help command to confirm. Next, we create an account on InMax with the default flag so that when we run commands without specifying an account, that account will be referenced. Create an account of Bob as well. Alice issues 10 tokens on Intmax, which we call Alice tokens since they were issued by Alice. Alice transfers their Alice token to Bob. Check the balance after the transfer, and you can see that Alice has 9 tokens and Bob has 1 token. Let's take a look at the interoperability feature. First, write the private key to the .env file. Be careful not to transfer any of mainnet's assets, since the key originally written is a private key for testing purposes. Rewrite this part to your private key. Deposit is on scroll at the address corresponding to the private key. 0.05 Ether is enough for testing. Next, Carol makes a deposit on scroll at the address corresponding to the private key. Next, we create Carol's account. Switch to Bob's account and issue a Bob token. Check that the balance has increased. Next, make an offer to Bob to pay 1 Bob token on Intmax if Carol pays 0.001 ETH on scroll. This operation will take 1 minute. If it succeeds, the offer is accepted. If it succeeds, the offer is accepted, and so record the offer ID. Accept the previous offer on Carol's account. Replace the part marked offer ID with the ID you just received and run the InMax activate command. Looking at the Carol's account, we can see that the Bob token has indeed been transferred. We will now develop an app for InMax to interoperate with the other EVM compatible networks. Create npm project, install Node.js if not already installed, and install Hardhat. This operation takes 1 minute. Create a Hardhat project. Okay, module install is finished. We can see that the lock contract has been generated. This time, we will create a simple auction contract and explain how to create a normal contract. So the first one is without InMax. Install the Nessa module. Make it possible to import InMax interoperability plugin contract. Once installed, we fix the Solidity version. Back to the simple auction contract. We can import the offer manager contract by writing it like this. From here, we will write code using Intmax. In the constructor, we store the address of the offer manager in storage. In the constructor call the register function. This function corresponds to the Intmax I register in the CLI, and once a simple auction contract has transferred a certain amount or more through the offer manager to the message sender, the token specified in seller asset ID is transferred to the seller amount to your address on InMax. Seller InMax is written to be updated with each bid so that it's returned to you when there's no bid. Save the issue offer ID to storage. Next, we modify the bid function. We use the update taker function to allow the higher bidder to specify the address to receive the token on InMax. Finally, the claim function is modified. If there's even one bidder, we call the offer manager's activates function, which triggers the transfer on InMax by sending ETH to the larger bidder function via offer manager. Also remove the code for withdrawal amount on line 18, which is forgotten in this video. If there are no bidders, call the deactivate function to pretend there was no offer. The withdraw function does not need to be modified. The send price function is removed because it is no longer needed after the previous modification. Finally, check that completion passes. Deploy contract to scroll and prepare script to execute transaction, register RPC URL and private key for scroll alpha testnet. The private key is obtained from the .env file. The address specified in the .env file must have the scroll alpha testnet ether deposited. Install .env library. I copied the script from sample auction app. The start auction function is executed by giving the seller's Intmax address. The minimum bid is set to 0.001 ETH. Bid runs given the Intmax address of the buyer, bidding at 0.02 ETH. this function get auction info, get the current bidder. Run claim. It fails because the auction has been open for less than 2 minutes, so just wait for a moment. I run claim again. This time it succeeds, and you get an explanation of what to do on InMax. It shows the balance before activating to see the token moving on InMax to the auction winner. Activate the offer. After the activation, we can see that the tokens have indeed been moved. Finally, the seller performs a withdraw function to receive the winning bid. So this is the example contract, an example project. And finally, the receipt is complete and this auction is now over. Thanks so much for your time.